So good evening to all of you. We have had intense discussions on AstroSat and results from AstroSat over the last 3 days, and also lessons learned. But it's time to look forward, and we have been. It's not that we haven't been doing it. We have been doing it from, as you said, from formally from 2018 when there was an announcement of opportunity, and there are already proposals submitted to ISRO for follow up on AstroSat. When I say follow up on AstroSat, it doesn't have to be like AstroSat, but something which is connected with high energy astrophysics. Uh, uh, and because we are limiting it to that, otherwise the area will be very, very wide. Um, and we now, after that announcement of opportunity, as he said, in 2 years back, there was an SSRF roadmap formulated for each part of astrophysics. So we are now looking forward to see how this pans out. So let me now start with the panelists. I would like each of the panelists to give their views for say 3 to 5 minutes on specific topics of their interest. So I first invite Mudit Srivastav. He is a professor at Physical Research Laboratory at Ahmedabad. He has worked with the UVIT instrument, and I would like to invite you to share your views on particularly UV astronomy, how we can go forward. And there have been comments right from say 2 years after AstroSat that we are not able to see some of the X-ray targets because of the constraints in UVIT, which we have to agree to because UVIT is a very sensitive instrument. So do you think for future we should go, the UVIT and the X-ray instrument should go together, or should there be two parallel missions which can observe simultaneously if needed?
Yeah, thank you, Professor Sita. Now, the importance of UV astronomy, I mean, from these very proceedings, it's been very clear, and various authors have mentioned that a large fractions of AstroSat papers, close to 50%, have come from the UVIT. When I was trying to use the UVIT data for my own work, then I came across a very interesting, lacuna. I mean, I've been observing some kind of transient, and then I realized that the last fully dedicated UV spectroscopic mission, it was IUE,
IUE.
and that finished in mid-90s. I mean, it's been 30 years that you don't have spectroscopic capabilities in UV. Of course, Hubble is having, of course, but the Hubble is kind of the subscription level there. So if you talk about the spectroscopy, that is, I mean, amazingly, and I've been talking to lots of senior people that why is it so? I mean, why, as a facility, why don't we have spectroscopy in UV? It's such an important field. So this is one thing which I noticed. Even right now, if you look at the various UV missions which are being planned across the world, mostly imaging. The only one mission which I could think of, which I'm aware of, is UX, Ultraviolet Explorer, Caltech Group, but it would be coming in early 30s. So still, in UV astronomy, I see that there's a great need for spectroscopy. It's been missing for last 3 decades. I don't know why. So that's one part. The second thing which I realized that some of the, I mean, I don't know, don't want to use the word shortcoming, because lacuna would be the right word, with the UVIT, and we all know that not able to see through the galactic planes is one of the things which possibly we should be thinking very carefully whenever we'll be planning the next UV mission. Synergy with the soft X-rays. On the first day of this this conference, Professor KP Singh, he in great detail explained the physics of the novae and related steps, where you do expect, and novae are not the only things, lots of explosive event, you do expect the synergy between the UV and the X-ray. So the synergy, and those things are happening in the galactic plane. So these are the two things. And The third thing is the emerging field of transients. You know that LSST has come up and it will be churning out the transients at a very high rate. So not only the UV spectroscopy, then I was asking in one of the conferences that even if LSST is giving you the transient and you want to study them for the spectroscopy, those, the transients are at the magnitude of 20. How are you going to do the spectroscopy,
Fine.
even in optical of 20 magnitude source? Do you have a large aperture telescope? I mean, thanks to our government and as Professor Subramaniam announced that now the big telescope is coming up. So that thing is taken care in the ground-based optical NIR, but what's
Correct.
happened to the
Ultraviolet.
UV ultra? The last point, which again I came across a couple of years back when I was trying to observe a transient with the UVIT, some transient happened, and within few hours over the phone call, over emails, I talked to everyone, everybody was on the board, the chairman of the time allocation committee, everyone. But the fastest we could get that observation done was in 2 days. So if we are looking forward for the transient, then capturing them fast, whether across any waveband, I mean, let it be X-ray or in UV, should also be something which we should be very carefully think of. So those are the things which I could thought for the future missions.
Yeah, thanks, Mudit. Yes, AstroSat was not designed to be swift at all. In fact, if Pandian was here, he will say, AstroSat is an elephant. Don't compare it with Swift. So it will take time to. But also the decision making. I think it's not just the satellite movement. It is, if you want to study transients quickly, the decision making process also has to be fast enough. And that's one lesson we have learned. Okay, and so now, so that's on UV. You think UV is important, and also there is importance even when it comes to multi-wavelength observations with the same platform.
Indeed.
We now go on to X-ray. AstroSat has done very well in both timing and broadband spectroscopy of various X-ray sources. Sudeep Bhattacharya has been involved in the analysis of several neutron stars, both timing and spectroscopy. I now invite him to say whether there is, we already heard from Santosh that it is worth going for another spectroscopic and timing mission. However, how would we be doing it, and what would be the minimum requirements if you want to go post AstroSat for such a mission?
All right. So I'll talk about a large area X-ray spectrotiming space mission concept with European collaboration, which is a very recent development. We call it XSAT, and Enrico Bozo mentioned this name in his talk. So why a large area X-ray spectrotiming detector is needed? To understand that, I'll very briefly mention the two of the most significant contribution of AstroSat. One is this LAXPC instrument, which is the spectrotiming detector on board AstroSat. It has significantly advanced our understanding of the extreme physics of compact object, and most of the Indian X-ray astronomers work in this field. And thanks to AstroSat, there is this X-ray astronomy community of India is now very large, including students, researchers from colleges, universities throughout the country in an unprecedented manner, and thereby AstroSat has spread the culture of scientific research very significantly. Next slide, please. So, with considering this legacy of AstroSat, we need to do possibly two things. One is to build on the expertise and knowledge obtained using AstroSat, and a large area X-ray spectrotiming detector, which is much larger than AstroSat LAXPC. And Dr. Sita was saying how large, so we'll come to that. Could make India a world leader in X-ray astronomy. This is the first point. And we should possibly try to sustain and further grow this large Indian X-ray astronomy community established as a result of AstroSat project. The research by this community primarily requires a large area X-ray spectrotiming detector, because this kind of detector actually can sustain a large community, because for the simple reason that each observation which can give a publication is usually short. So it can sustain many people. Next slide, please. So with this background, there is an ongoing discussion among Indian and European X-ray astronomers about a plausible Indian X-ray space mission XSAT, which may include, among others, a European spectrotiming instrument, which is a state-of-the-art, commercially unavailable, silicon-based large area X-ray detector. And this instrument, which has a significantly larger capabilities compared to AstroSat, 10 times the area, 10 times effective area, and any similar instrument, previous or current, any X-ray instrument, at least 10 times than the area of those instruments, will sustain and further grow Indian X-ray astronomy community and further spread the culture of science. And another important point, the proposed mission will also align with India's participation in large international ground-based science projects such as SK in radio, TMT in optical, and LIGO India in gravitational waves in X-ray wavelengths. Next slide, please. So I'll not describe this. We are talking about 3 instruments. The first one is the large detector, which may come from Europe. The other 2, one is a soft X-ray detector, and the wide field imager may come from India, and Santosh has already shown them. So next and final slide. So this figure actually says everything. This is the effective area versus energy for various current and future and previous major X-ray instruments. And all those cards at the bottom here, these cards are for various previous, current, and even future, because Athena, the blue card, Athena will be launched in 2038, not before that. So even future space mission, these are the effective area. While we are talking about for this space mission a curve given in black, actually we are not currently talking about 10 meter square peak, which this curve shows, but that black dot which shows 5 meter square, we are talking about 5 meter square peak. But even then, it is about 10 times larger than any X-ray instrument ever made. And this shows that XSAT will not be an incremental improvement, but it will be a giant leap in science and technology, which will make India, along with Europe, definitely a leader, world leader of X-ray astronomy. And that's all.
So, yeah, while we talk about spectroscopy and timing, and people think, okay, AstroSat has done, next what? And Santosh actually briefed us on also the efforts taken on by several scientists here in India on future polarization instruments. That's another area which has opened up with IXPE and also the XPOSAT. And so next we will ask Professor Biswajit Paul, who is the PI of the POLIX instrument on XPOSAT, on the lessons learned from POLIX and what future scientists who are going to be involved in polarization payloads should take care of, and any other lessons also learned, because he has been involved right from the Indian X-ray astronomy experiment in 1996 all the way to AstroSat and XPOSAT.
AstroSat has been very successful.
Mike.
As we heard over the last 2.5 days in all the lectures and the posters and a lot of other results which have not been talked about here. We generally don't talk about, but luckily Rao touched upon it today, where AstroSat has not been successful, is in increasing the human resource for instrument development. And I don't know how to answer that and what needs to be done, but definitely we need a lot more instrument development activity in the country. Like today, when we are talking about 3 possible missions that Santosh mentioned, irony is that these 3 are the only possible ones, it looks like. Okay, if you are talking about 3 missions should come out from 30 proposals. Okay, and the activity for those remaining 27 are probably not happening. Okay, so we need, nation-wise far more emphasis, and we need to have an ecosystem for instrument development. That's my own feeling. Now, coming to what Dr. Sita asked me to talk about, I will briefly touch upon all the three instruments that were mentioned. The first one is Daksha. In my mind, and probably this will also be the time sequence, because readiness wise we are probably closer to it for Daksha, and then comes the large area detector and the broadband polarimetry, which will require hard X-ray optics, will probably be take much longer time. So on Daksha, in addition to all that has been thought about, one point that I want to emphasize is a Daksha mission, when it goes up, it has to be completely ready, okay, to deliver all transient detections immediately. Okay, very fancy offline learning is a very good learning indeed to be applied to future missions. That itself does not advance the science. Advancement of science will come when the Daksha transients are announced worldwide immediately. So that's a key point of Daksha, I think, that we need to keep in mind. Coming to the large area timing mission, there are several things that we'll have to do very, very well. A few key things I want to highlight is, one is that such an instrument must go along with an all sky monitor. Okay, you will otherwise have an elephant learning blindly. We need to have a very good idea about the context of the X-ray sky at all times, and then make best use of this instrument. Another thing for such an instrument is, we often talk about calibration, and in our mind, often calibration means the energy resolution calibration. The effective area calibration, which is actually very tough in low energy band, and my colleagues on the expect team has done a very good job for that eventually. But doing that for a very large mission with 60,000 square centimeter area will be extremely challenging, and that needs to be addressed. Whatever support required in terms of infrastructure, in terms of analysis and so on, large group for participation in it, all of that has to be worked out. Another very significant difference between how RXT operated and how AstroSat operated is about its agility. Okay, ability to reorient the mission quickly, both the satellite having this ability, and the decision making and actually implementing it, all of that has to go at least as well as RXT or even better. I mean, for example, we were talking about when a transient goes up, we usually do not have many frequent sampling of a transient. It's not possible if a transient is up there for 60 days to continuously look at that object. We should be able to revisit it as frequently as we want, often with maybe just 1,000 seconds exposure. Okay, with the RXT, for example, there were sources where there are 500 revisits. Okay, and Loma 6 binary with an eclipse, only 800 seconds or 1,000 seconds observation is required, but it has to be revisited precisely at that time. Okay, that was possible with RXT. That's probably far more limited in NICER, but if we talk about future mission, we must have that agility, and we prepare for that now. Okay, that's an absolute must for a large area mission. Another is all sorts of systematic has to be brought down. We were talking yesterday about systematic of 5%, 3%, and so on. When you talk about a larger mission, 5%, 3% is not the number. Okay, even for moderate sources, your statistical variation will be of the order of 0.1%. Okay, and if you instead use 1% systematic, you are basically compromising the effective area of the instrument by a factor of 100. Okay, so understanding background, understanding instruments own systematic, these are absolute must if we want to make full use of a large area mission that's being talked about. Coming to polarimeter, all that Polix has faced a very difficult situation regarding its background. Background itself is not very large. It's the variation of the background, which is fine. In X-astronomy, we all know that background is variable and that can be modeled, brought down. In case of Polix, what we have faced, and that is not faced by or not needed for any other X-astronomy mission, is that the direction from where the background comes, the charge particle direction, that is highly variable, and both in time and space. So any large area instrument is preferably to be avoided for broadband polarimetry mission. Going from low energy to the highest energy that is possible with focusing optics, we must go for focusing and lowest energy, smallest instrument size, which, however, will be difficult in the medium energy band. So I was very happy yesterday talking to Radhakrishna that he is exploring the possibility of building photoelectron polarimeter by different gas composition, different gem size probably, to adapt it to medium energy band. Because otherwise 8 to 30 kV will always remain a gap. With focusing in hard X-rays, having a Compton polarimeter at the center will preferably work above 20 kV. And gem-based photoelectron polarimeter as they are now will work up to 8 kV. 8 to 30 kV is far more challenging band, as we have learned from AstroSat. And there again, no matter what polarimeter we choose, preferable not to use large area one. Large area one, on paper may give same sensitivity, but suffer a lot more from unknown directionality of the charge particle that come in. So I guess that's all I have.
Thank you, Biswajit. Yeah, I now move on to Dr. Radhakrishna. He is, by the way, for those who don't know, Biswajit Paul is a professor at Raman Research Institute, and Sudeep Bhattacharya is at the Tata Institute of Fundamental Research. Dr. Radhakrishna is at the Space Astronomy Group in URSC, Rao Satellite Centre, and he has delivered this very successful EXPECT instrument, which is flown on ExpoSat, and the announcement has been made for proposals, and we are observing proposal-based candidates in the sky now. So he is also working on a gem-type detector for polarization in low energies. So over to you, Radhakrishna, on your challenges in developing the detectors, and as Paul said, focusing optics also to go with it. Yeah.
Anyway, my task is to talk about the development of photoelectron polarimeters. And the polarimeter is in X-rays. Already Santosh talked about the development activities, broadband polarimeter, what we are trying to make. And also Biswajit highlighted the science requirement, which I don't have to dwell upon here for this audience. And coming to the development actually, so we at Rao Satellite Centre Space Astronomy Group, we have taken up this gem-based soft X-ray polarimeter. In fact, when we started this gem activity, it was not in the context of polarimeter. It was like, the possible future applications. So as a general detector, we have taken this development. And it has taken quite some time actually. So now we are in a state where we have developed end-to-end system where we can see a photoelectron track, a track of size of around 1 to 2 mm in the gas mixture. So we could image the projection of this, and from that we can derive polarization direction. That is the stage we are in. However, there are a lot more engineering challenges now, which we are confident of overcoming and resolving in future. So coming to, there are a few questions raised, like one is about the collaboration Professor Rao mentioned, and also the time, how long. Professor Tandon had asked this question. So just to tell from my experience, as I said, GEM development and coming to complete end-to-end system development has taken about 14 years actually. So, however, the team, in the meantime, team has almost same team has delivered two payloads for Indian mission, Chandrayaan and EXPECT. These are the two payloads which are delivered. So that way, again, the critical mass of experimental scientists is one question which comes into picture. That is the one probably delays our development.
Most critical.
Yeah.
Most critical.
Most critical. Having said that, not giving up is very important, because there will be questions asked, how long you do this and when it will come, etc. But it is our passion which we have initiated, and taking it to a logical conclusion is one thing. So that is one thing. And also about the collaboration, again, the initial activity was through collaboration. We collaborated with the PhD students in IISc, not astronomy experimentalists They are just instrumentation, radiation detector students. So we collaborated with them. In fact, the same GEM has delivered about 3 PhDs in experimental and instrumentation area. So that's what I wanted to say. So the journey, even though it is long, but it is fruitful, and we are in a position now to confidently say that we can indeed develop a future polarimeter, which is, based on this GEM technology. And another two more things. Since you all know that IXP is in orbit now, and I think close to about 70 objects have been seen by IXP. And it is important, while we talk about broadband polarimeter, it is very important the community here. I know some people have already, worked on IXP data. The scientific community also gears up to the challenge to analyze polarization data, and also possibly bring out the shortcomings, or if any, from IXP. So what would have the additional measurements would have helped the analysis of IXP data. If those kind of things come to the instrumentation team, probably the future, when we really configure the final configuration, definitely we can tune it better. So that is another thing. I think I would request the scientific community here also to look at IXP data, and communicate with us also what is shortcomings, if any. So that is another thing. And Biswajit just highlighted the medium energy polarimeter. This is another thing we are confident, we will soon discuss with all the experts. We are confident that the same technology can be used for medium energy polarimeter. It has certain advantage, which we will soon come out with those activities. And we have currently very good handle on end-to-end simulation, and the proof of concept we have demonstrated, and we are moving into engineering model development. And with the one final point is, uh, again, the Polix also has demonstrated that there could be a lot of unknown which we may have to deal in the space. And in that context, also, gem detectors are very sensitive for discharges in space. So it was suggested, in fact, Dr. Srikumar's committee, when they evaluated, while broadband polarimeter will take longer time, we can have short-term missions, which can be like tech demo. Along with the tech demo, if we can do some small niche science, that would be one very good thing. With that, in that context, I think we will configure it. And that's what I just wanted to say. Yeah. Thank you.
Thanks, Radhakrishna. Varun Balerao is from IIT Bombay, and he has worked a lot on transients, and he has already proposed on Daksha for studying particularly gamma ray bursts, but we'll see how well we can adopt for the other transients too. So over to you, Varun. Why are transients so important, and what can we do about it?
So I'm going to take this in a slightly different perspective, because instead of being from a science institute, I'm from an engineering institute. So that makes us look at things a little bit differently. We've been talking a lot about what comes after AstroSat, and as Santosh and many others pointed out, we've been talking for a long time, right? Now, great science begins with a good idea, but it ends by executing that good idea. And we've developed this. We started with 19 missions proposed, which were then shortlisted by various committees. They were reviewed, they were given seed funding, and then 3 missions, including Daksha, Pratush, and Insist, came out of all of that. And the missions then went on to build lab models. We went on and garnered support from around the world. So, for example, we actually got a letter from the NASA in charge of astrophysics saying that Daksha meets the decadal requirements of NASA. And unfortunately, it's not on our roadmap. So I've cut the lower part and put it up here again. They're essentially saying we look forward to working with you on this mission because we are really interested in this. right? And all of this now put together, we all have all these big goals. We want to be scientific leaders. We want to have deep tech that is being built in India. We want to do human resource development. But then, as was pointed out by Biswajit and Radhakrishnan and so on, we have the same 30 people who are then having to play with 30 concepts of instruments instead of getting together and building one or two of them, right? And every time we have a conference like this, we hear of 2 new mission proposals that are coming in, and that is not at all sustainable, right? So according to me, what we really need right now is something that is okay. Something that we need is on this side of the slide, which is that we actually need, and this is, for example, something that we have several foreign colleagues here, and a question which we got asked is, okay, what is the time scale for Daksha? And I don't have an answer, right? We need well-defined timescales for every mission. We need to take decisions on whether they are happening or whether they are not happening. And then we need to respect those decisions and move in together to build the next great thing. Because AstroSat was possible only because the community came together and worked on that. If we imagine that we kept proposing 5 separate payloads instead of 5 separate satellites instead of payloads on one satellite, and then every 2 years started coming up with AstroSat 2, 3, 4, 5, 6, nothing would have happened, right? And we needed AstroSat 2 to be launched before 10 years of AstroSat. And here we are still talking about what AstroSat 2 should be. So I think that is the main thing. We need well-defined timelines. We don't have an equivalent definition of phase A, phase B kind of studies. We need well-defined um, goals, and then we need to come together to execute them. I think that is what, and especially in engineering institutes where we work more with students rather than long-term manpower and so on, the driving factors become very different. We bring in a separate set of resources, but we also bring in a separate set of constraints. And as we want to expand to increase more academia, that was what was there in Rao's final slide as well, we have to also understand how to work with academia, which is very different from how ISRO and research institutes work. So those are the points that I would like to put forward for discussion about this.
Yeah, so you're bringing in another cultural thing, because in AstroSat we had between scientific teams and ISRO teams, and now you're saying the academic institutions are even different from the research institutions. Okay, yeah, so yes, we need to make a decision and we need to go forward. Thanks, Varun. And finally, we come to Sankar Subramaniam. Uh, he is heading the Space Astronomy Group in Rao Satellite Centre, and they have worked on several payloads um, proposed by them, and also those which are proposed by other teams and for which they have given a lot of support. So, what is your view on going forward in future missions? Particularly, everybody has addressed on this critical manpower, human resources requirements, and becomes very critical, especially for instrumentation. So, what is your view?
Okay, thanks, Sita, and thanks to all speakers for covering major aspects. So I'm not going to talk anything new apart from what I have gathered from this 3 days of conference. I just put 4 points in here, which I will try to explain and see how we can. I mean, it's again my own thinking, how we can proceed forward. The first word I learned in this conference is demonstrated capability. This was told by Kiran Kumar by himself. And the second word I captured is the disruptive ideas and technologies. That is, you don't go with the bandwagon. You think of something disruptive, the whole system. And the third one is the be open to your colleagues. You discuss among your colleagues of any issues so that you can sort it out before it goes out of your hand. And then the fourth one, I think many of us are discussing, is the community building, which is essential, especially for instrumentations. I still feel it's not only for instrumentation, even for the quick science analysis, as well as the trying to bring out the data analysis and data processing techniques. So these 4 points, I will try to slightly expand it in 3 different arena. The whole sequence of our space missions, we can broadly split into three areas. One is pre-launch activities, and the other is the in-orbit or during the science phase operations. And the third one, where both pre-launch as well as in-orbit will come, is related to the on-ground activities. Okay. So in the pre-launch activities, which is very, very, very important, I mean, many of you would have looked at it, is the definition of the mission, putting the science goals into it, and bringing the instrument requirements into it, and also developing demonstrated capabilities on the ground before even we go to the space. I think that is something which is needed for us if you want to be successful in any space missions. To do that, I mean, what is needed and what probably is not fully addressed in our previous mission is, again, talked about in the meeting, is the handshake between the scientists and the engineers, which I think is much better now compared to the earlier days. Why it is important, I will tell you. Usually when you define a mission, what we have is the science requirement document. That is, you define your science, what you want to do, and the science requirement document is translated into a instrument specifications. So there is a link between the science requirement document and the instrument specifications, which the engineers have to build the instrument for. When you do this, I think a strong handshake between the instrument team and the science team is essential, so that there is a give and take from both from the science point of view as well as the instrument point of view, so that you don't think of an instrument which is not possible to build, or you build an instrument which is not going to give you any great science out of it. Okay. Many of the things we try to address it, I think from both from AstroSat and Aditya point of view, if you look at it, we go into a niche area where other missions don't cover that particular area. So in that way, you don't overstep on other missions, and you can easily build, I mean, put your science into a strong, strong area. Once that instrument specifications are defined, then what the next step is the development of the instruments, which we call it as in URSC as a technology readiness level, TRL. At least we need to reach to a TRL level of 4 before even we think of putting up a proposal to space agencies for funding. I mean, this was not the case in previously. I mean, at least I can say both for AstroSat and Aditya, the TRL-4 was achieved after the mission was approved. This will change over time. And then when we start building, I mean, if everything goes well, you'll meet the specs. If it is not, if any difficulties are there, there'll be some compromise on the specs. That's where again the science working group comes into play to see what the what the compromises one we go with that. So that is in the pre-launch phase. If that phase is well cohesive and well gelled between the scientist and engineer, I'm sure most of the missions will be successful in the future. Then comes in the in-orbit phase, where the critical operations are the CAL exercises, the PV phase, the performance verification phase of your mission. This is an operations where we ensure that the payloads are operating to the required specifications. And I mean, even though after all the ground tests, you may see some surprises. I mean, as we have seen it in some of the missions. And if you want to quickly turn around and understand what is the issue and then come back, again, this is where the science working group comes into play. So once if the gelling of scientist and engineer happens in the pre-launch phase, the same team of people can quickly address this particular phase and then try to provide some solutions which will avoid any delays in making the instrument operational for a science missions. And then the final one is the on-ground activities. I think this is the phase where I think we can take a lot of support from a gamut of people here, wider community, because the data pipeline is something which the payload team or the hardware team takes it at the last exercise, because their first priority is to deliver the payload. So at that initial pre-launch phase, if there is an identification of the data pipeline team, which is coming from outside of the hardware team, and they can support building up their data pipeline quickly.
No, there is one point I want to make on this. It's not the identification alone, because I know in AstroSat the teams were identified, but the point is still hardware progresses to a certain stage. This part is not taken very seriously, which should be done especially for transient studies.
Yeah.
It should be on the same level of what do you call speed
So,
as the hardware.
so one thing which we tried to do it in Aditya L1, but we couldn't succeed is we want to have this L0 to L1 done during the satellite test level,
Yes.
so that you also test through the data pipeline during that phase, but we couldn't succeed in that. So I think that must be something which we have to focus on to do that. And finally, coming to the community building, yes, I think this is something which we also face. Because to build a science payload and qualify them requires a lot more people than what institutes or even the ISROs can offer to. So this is where the larger community build-up will help in. And I saw in Professor Rao's slide on some of the aspects which you have put in. I also note down that something like a space science kind of a place where people can come
and work
do a
together.
hands-on experience, hands-on what you call development, hands-on data pipeline at the young age. And if we focus on few modules which we can develop it, which will help in many of our future missions, that will help a lot. Thanks a lot. Yeah.
Yeah, thanks, Shankar. Since we are hearing, we only a small fraction of people involved are here. I would like you all to take back this message. If any of you are interested in any part of hardware development also, you don't have to take the whole think that you have to take the whole responsibility. If any of you are interested or any of your colleagues are interested, please take back this message. Please send back an email. The SOC email will be available for a month or two. And please send back that you are interested so that respective teams can make use of this. I have a hard time cutoff of 4:45. So they've given me an ISRO cutoff. So if there are quick questions from the audience, we can take it. Yes, Rao.
This is specifically addressed to Radhakrishna. Okay, so you said that you took 14 years to develop the gem detector. Of course, a lot of learning on the way and etc. Now, this is a good experience. My question is that, is this experience transferable and scalable? For example, if you ask a new IIT to develop thing, if you say that it will take 15 years, is unviable. But is there a method to transfer experience, be a mentor to them? Any new detector development can be done in 3 years. Is it possible?
He already told one thing, that parallelly he was working on two payloads.
Okay. That's okay. That's all right.
Parallelly, that's one thing. And
but
it
but
was
your
stop,
experience
start.
of, there is a lot of social issues
Right,
involved.
right.
I know that.
Yeah, definitely. I think
so. Can you act as a guide or a mentor so that this thing is faster in new center?
Definitely.
No, so can you tell some points which can speed up this?
Right. So I think this is the part of the answer is, in fact, in your presentation, you yourself have mentioned. I mean, you divide the activities and a lot of things can be done parallelly. That is the approach one has to take. For example, we have done initially a lot of simulation work. It took substantial time and parallelly developed GEM in-house, and then only we started, going to the industry, etc. So if we divide the activities into small subtasks and which can be taken up parallelly, then yes, that is one thing, one approach we can do, and mentoring is definitely possible. Probably may not be. New detector means obviously new things are involved, but the approach and these are the kind of things definitely we can mentor.
Anybody else?
It's not a very deep point, but something that Varun said is perhaps of the paramount importance. I was horrified to read the report of the roadmap if you look at the decadal vision document that America produces, there are a set of very specific prioritized recommendations. And the funding agencies go by that prioritization. And when we brought out the first vision document 20 years ago, more than that, probably 25 years ago,
Maybe more than.
there were a set of priorities. One was coronagraph in space, then development of hard X-ray detectors and so on. So now, long time ago, when I was a college student, I remember reading a Scientific American article by Phil Morrison about how termites build their hills. So if you go to an area, a lot of termites are building lots of hills. At a certain time, termites which build one hill, if they find another hill taller than that, then they abandon that and go to that. And this cascades till finally all the termites are building one hill. Now, I'm not saying there should be only one hill, but there should be one or two. I think the point that Varun made is extremely important. We are talking about far too many missions. At the same time, complaining that we don't have manpower to do this. This is sheer madness. Then the question is, who is going to prioritize it? Okay, and that is where this whole idea of democratization is in conflict, orthogonal to the concept of prioritization. So you people should sort that out. A group of people should be empowered to prioritize it based on various considerations. They will have to convolve all sorts of things, in particular, the size of the user community and the impact of the science. Just because you're going to publish more papers on LMXBs or quasi-periodic oscillation doesn't mean that we are making a great impact there. So you people, I'm not going to answer the question, but my innings is over. But those of you who are planning future missions must agree to a framework which will prioritize missions. Otherwise, it's not going to, we'll be talking about, he's right, we're still talking about the same thing. Okay, so
I mean, there have been these really brilliant expositions here, and all aspects have been covered extremely well. The question is, how do we move forward? So, first of all, you see this hall here is full of people, many of whom give very clever talks, and the standard is exceptionally high now, much higher than it was in the past, but also in absolute terms, it's very good work. So, and then there was nobody like this 10 years ago. There was nobody like this 10 years ago. So, and that one thing was AstroSat provided brilliant data, but some of us also created opportunities to where demand and supply had to be met. And somebody got a Nobel Prize for doing it properly. Right? So one of the institutions responsible was for IUCA, because we provided the platform, we continue to provide the platform when different people interact and they actually produce new science. So now what is required is the same kind of development in experimental area. Right? Because as he said just now, Radhakrishna, you have to parallelize the activity. So in the theory and in computation, we use GPUs instead of CPUs now. So you need that kind of a transition where you parallelize it. When you parallelize it, you require good management, because otherwise nothing gets done. Right? And even in the GPU, the management is extremely important. Similarly, so what I feel is that you need an intermediary, and that cannot be a small institute like PRL or IUCA or IIA or anybody. But I believe that the IITs can play that role, okay, of providing a platform where all the bright minds from the universities can get in. And you see that most of the people who are doing so well now, they don't come from the urban centers. They come from far off places. So that is where the bright minds are. And that is where the bright minds are available. Right? So I can imagine the situation where I think we all need to come together and talk about this possibility of, because Varun emphasized it's an engineering institute, and that is what we need. The thing is that there is no money in the IITs. You know, you go there and then they say, fine, we'll do whatever you want, but where is the money? Show us the money and then we'll give the results. Now, that kind of an approach is extremely good. Because, you know, otherwise you make vague promises and you don't deliver anything. So I believe that if we all get together and talk sensibly about this, we can convince our financial masters, right, that with relatively small funding, uh, provided to the IITs. Because now you see that, look at the large groups which are developing in the IIT. Look at what's happening in the IIT Indore, IIT Kanpur, to a smaller extent, but a very important extent in IIT Bombay. Right? So I really feel it is going to be possible to set up a system like that, where you get in funding, a lot of leverage will come, and you must never ever forget that all the IITs have access to their alumni. We also have alumni, but their alumni are different. Right? So they have the money, and they are willing to fund something. First of all, it is blue sky, and secondly, it should be a blue sky that you can get to. Right? So I feel that there is going to be a new direction. And one last point I wish to make is that it is going to be incredibly important for ISRO to move forward. Now, we just heard from Annapurni about these two very important ground-based things to be we have been approved. So just imagine that ISRO goes ahead and the government goes ahead and approves 2 space missions, then this whole hall here is completely fixed for their careers. Okay? Because you're really talking of long term during which this is to be done. Right? So we should try very hard, and for which we require better dialogue uh, between the two sides of the table. And even though I have a foot on each side of the table, and I have very good, um, I mean, I got communication with everybody, I feel nothing is happening. Right? So I urge all the ISRO people who are here and those who are not here, okay, to get together with the science people and try to take this matter forward. Thank you.
Thank you. Thank you. So we come to the end of this panel discussion. Thanks to all the panelists. So Anuj Nandi, the SOC member secretary, has also given me this difficult task of summarizing the whole meeting, and that's not possible easily. So I'll just try to make some points. I am just amazed at the variety of results which were presented in the last 3 days. And it's very heartening, you see, to know that now there are 14 Lyman continuum leakers as against just one earlier. There are neutron star binaries from which we have detected burst oscillations and even their evolution with time. And black hole binaries, our favorite GRS 1915 with a new discovery of a new variability which was not known earlier, etc., etc. And of course, galaxies with different populations. And we are now using JWST also to find what are the constituents of that, of the star forming regions, and no way from other galaxies, and how we are going to study those in future, etc. So it has been a very, very fruitful meeting according to me, and I hope you all agree. But having said that, even with AstroSat, there is still scope for improvement even after 10 years. It's always the case. I mean, I think scientists are never satisfied, and it is good because that's the way we improve. So we will still try to see how many of those we can address, and how we can take a focused approach to it and see how many of them we can solve. Um, um, AstroSat has led to a large team of scientists, both within the country and outside the country, who are now able to address both UV and X-ray, both on instrumentation calibration and data analysis. So having created this, I think we should make the best use of this community even for our future next experiment. So I request on the ISRO management, I request Jaswinder Khoral that from next week he can again don the hat of program manager of Space Science Office and help us in going forward of how to clearly we need to move forward quickly on the next science mission. I know there are Chandrayaan missions and planetary missions, but just like from 2015 to 2025, we had Chandrayaan 2 and Chandrayaan 3, but we had AstroSat, Aditya L1, and ExpoSat. So we need a variety of missions to address the various community members. And so I would like ISRO and the scientific community to come together to quickly prioritize what way we should go forward, because this is the need, and we need to quickly start on the developing of the qual model at least, because we know that we have face hurdles when we develop the qual model, and we can quickly go to the flight model. Um, while we can go to TRL4, etc., clearly for qual model we need ISRO support, and unless we have the ISRO confidence that we are going to go forward with this mission, we can't even go for extra funding, extra support with various other institutes. That's one important thing we need. They need one paper on which they can seek support from various people, not as individuals, but also as institutions. So I think that is essential. And if you say that we are willing to give this kind of mission, now we have this 7 proposals. Now you prioritize and come back within a month. I think the scientific community should again go back and do it. I mean, when I say scientific community, please address each of those verticals in that SSRF independently, because there's a lot of wavelength difference and requirement difference across the wave verticals. So this is a request to the program office.
What K.P. Singh has pointed out is that everybody has said so many things except the young people who are going to do it all. So even if it means 5 minutes more, so please ask 1 or 2 young people to come and say what they feel.
Yes.
Yeah.
Sujay Mate is there. He wants to
speak from here. No, I think I resonate with most of the points here. I am personally actually inspired. I've started working on AstroSat, Polix and all, and I love building instruments. And just want to highlight the same point that I would like to come back and work and like contribute, but I don't see it going anywhere. So until something is moving forward, it just makes me, like to do that. So that's resonating with a lot of people. I've been talking to like, what is after AstroSat, what is after ExpoSat and all. So that is something, it is not just my word. I think it's like a lot of young people, like people around, like my colleagues are like PhD students or senior postdocs. I'm pretty sure like if I ask this, a lot of hands will be raised here. So that's like community needs to decide and do, and then there are for sure people who will help, but we need the senior people need that to do that. And then we will help that.
Guide.
Yeah, we need the guidance, we need some clear direction on what to be done. And
Yeah, so
anything which is okay that is to be done. Yeah.
sure. We are very thankful, Sujay. I know you have both expertise in AstroSat modeling and ExpoSat modeling. And I already told you we are going to come back to you for our pending actions on AstroSat. Yeah, we need to actually, as Rao said, we need to identify first what is to be done in a very focused manner, and then say what is the expertise needed, and then go to the younger people, younger team members, to actually seek their help. And that's where we come together. He said coming together is very, very important. And that, huh? Who are we? We is, as he said, the senior and the team members. So that's why everybody needs to come forward.
See, we heard on day one that we are inspiring young people. I got inspired by meeting Kasturi Rangan when I was 19. Now, 23 years later, I'm still waiting to decide what to do next. If
So
a
he's
mission is defined, I will drop the chair tomorrow and join that mission to complete it. But we need ISRO to come forward and say, this is what we are building. Everything else will fall in place.
ISRO should not say what you should build. ISRO should say, as I said, ISRO should, if they can give a
We,
commitment for
Sita,
a particular mission,
Sita,
they need to
there
decide.
are 4, 5 different written documents,
I know.
each 100 pages long, which has prioritized and submitted reports, right? Until money comes into any one of them, 1, 3, 5, whatever it is, as long as we are all competing in different sports, we are not going to win the Olympics. We need to team up and do one sport. Now, that sport cannot be played unless there is commitment to see it through. Right? For example, right now at a place like IIT Bombay, none of my PhD students, I have a group of 25 students right now, none of them can define Daksha as their primary topic, because if they graduate saying I worked on Daksha and Daksha never gets launched, they are going to be jobless for the rest of their life. So the community has defined this. Following up your 2004 vision document, there was a new vision document which did this. SSRF did this. Mega Science vision document did this. The Chintan Shibir that Santosh talked about did this. This exercise has been done 5 times in the last 10 years.
And I'll tell you, Varun, from my own experience, we keep talking this, and in the initial stages, it's a long wait for the scientists. I have known it from the 80s. But then, when the satellite people approve it, they go galloping forward, and we are finding it difficult.
We
to
will
catch up
come
with them.
together and catch up. That is, see,
so that's also there.
The 80s, shouldn't we move forward?
Yes, that's why I said we need a commitment, and we need to, from the scientific community, we need to prioritize. That's it. Yeah.
Not to say a word in this conference. Look, when I joined TFR, the culture of research was different. Everybody worked in groups, and the language used was, we are doing it, we did it. But over the years, culture changed. Now I did it, I am doing it. So you are all sitting here. How many academic people are in each team? You can hire 500 engineers. When we were building AstroSat, as a chair, I was signing 100 salaries every month. We can hire engineers to work, but that doesn't make your science payloads. Science payloads come when researchers, academicians come together. And now culture is different. We are talking about these young people. Who is willing to spend 12 years, 15 years for such mission and sacrifice the career while his institute or her institute will not recognize these efforts at all?
No, that's why Rao.
We are talking in the air. Hardware making is a completely different story.
I know,
Here
that's why
we are
Rao
talking
said.
absolutely different things.
If
I'm
we
sorry,
don't-
I had actually vowed to myself, I will not speak. I worked 46 years in TFR. And I've seen through X-ray astronomy, day one, I built the first payload in TFR. And then the group became bigger till I retired. Culture has changed everywhere. And hardware making is non-easy. Let me say that. Sorry, I buzzed in.
Yeah, that's why Rao repeatedly made this thing that unless you come together as a group, we will not be able to make it at all. So that's the lesson we carry. I think it's been a very happy meeting for all of us. Got together after several years, maybe decades. As I said, the SOC and the LOC emails will be open for at least a month or so. So in case you have some specific feedback to give, please send it to those emails. I now would like to call the SOC chair and the LOC chair to come on the dais, and the participants, I thank first on behalf of them, all the participants who have made this, as I said, a happy meeting. And And I expect that it has also been a very fruitful meeting to all. So let us now thank the LOC, all the members, and all the members of SOC for making this happen.
Yeah, thank you all for making this a very successful event, and let me also thank all my team members who worked very hard to make this happen. So thanks to you all, and I hope you all had a good time. If there are any suggestions, please let us know so that we can improve in the future. Thank you. And as far as Biswajit's point about AstroSat's speed of rotation, actually I have a couple of points, but maybe I won't take it up here because I don't want to hold up people. I can discuss that with you offline. Thank you.
As I said, the limitation on AstroSat is not the speed of the maneuvering from source to source. The limitation is in the decision making for transient monitoring. I am saying this as PI of AstroSat. It was not meant to be a transient monitor. So next time we know what lessons to take for a transient monitor. It shouldn't be, it should probably be on-board based decisions.
And now, as Sitama mentioned, that our SOC accounts will be kept open for next 3 months. Please do provide your suggestions, any limitations you faced or how we can improve it, not only for the logistic requirement point of view, actually scientific excellence point of view, as so many things we discussed, so many things we have not agreed. Please share us. I will discuss with Koral sir. Koral sir is the head of our program office. So please provide us the feedback. So let's thank you all. And before you disperse, have a high tea at the ground floor. Thank you.